Hello friends, welcome back to my channel. Today we are going to solve integral problem step by step. Watch this video from start to the end of this video, because at the end of this video you will able to solve question like this. Yes, question like this. So what they give us for all natural and the numerical function fn is defined by f of n of x equal to x power n over 1 plus x squared, all x belongs to real number, and they give us, given that in equal to integral from bound from 0 to 1 f of n x d dx. So what they ask us to find is calculate I1 plus I3 and deduce I3. C. Show that all natural p I2p plus I2p plus 2 equal to 1 over 2p plus 1. Okay, and D is about to calculate I2, I4 and I6. So what we are going to do at the first, we are going to find I1. So here what we are going to do, they give us this function, this f of x equal to x power n over 1 plus x squared for the value of x belongs to R, and they give us in equal to integral from 0 to 1 fn of x d dx. So what we have to know here, so they give us here we have n, and they ask us on a they ask us to find the calculate I1. So here we have I1, so here we have In. So the n they give us is 1. That we have I1 equal to integral 0 1, and they give us fnx we have here. So we have x power n is 1. Yes, n is 1 over 1 plus x squared dx. So what we are going to do, we are going to find the integral of x over 1 plus x squared dx. So what we are going to do here, we are going to use substitution method. So where we are going to take this 1 plus x squared, so let's u equal to 1 plus x squared. So the next thing here, we are going to find differentiating both sides with respect to this u. So what we are going to do, we are going to find du equal to, here we are going to respect to x equal to x dx. So then du equal to 2x dx. That will bring us, let's put these two here in this side. So we have du over 2, so equal to x d dx. So in our problem we have I1 equal to 0 1 x dx over 1 plus x squared. So this all we get that equal to du over 2, x dx equal to du over 2. So we are going to put du over 2, and this one we supposed that equal to 1 plus x squared equal to u. So we have I1 equal to integral from 0 to 1 du over 2 u. So we are going to find the integral of this one. So we have this must be put out because it is constant. So what we have 1 over 2 integral of 0 to 1 of du over u. So that this will bring us to ln of u. So we have 1 over 2 integral of du over u. So we have ln of u bound from 0 to 1. Okay, what we are going to do here, we are going to replace the value of u. We have 1 over 2. We are going to plug also the what we supposed here, u equal to 1 plus x squared. We have ln of 1 plus x squared, 0 and 1. Okay, so we have I1 equal to 1 over 2 ln of 1 plus x squared, where we have here 1 and 0. So we are going to put to plug this boundary into this value. We have 1 over 2. That gives us, when we put 1 here, so we have ln of 1 plus 1 square. So we minus this, also is going to plug here ln of 1 plus 0 square. So we have 1 over 2 ln of 2 here, because 1 square is 1. So negative, this is the ln of 0. So here we have 1 over 2 of ln of 2. This ln of 0 is ln of 1. ln of 1 is 0, so minus 0. So that is I1 equal to 1 over 2 ln of 2. That is I1. So the second problem here is to calculate I1 plus I3 and deduce I3. So what we are going to do is like what we do at I1. So where we have in B we have I3 plus I1. So what we are going to do, we are going to find this I3. So I3 means we have x power n over 1 plus x squared. So what we are going to do here, we are going to plug this n here, so that we have I3 equal to integral from 0 to 1 x power n, that is 3 over 1 plus x square dx. So we are going to find this integral and add it to I1, because I1 will have 1 over 2 ln over 2. So what we are going to do here, we are going to find the integral. So integral from 0 to 1 x cubed over 1 plus x square dx. What we are going to do here, we are going to reduce, because this value of x cubed is greater than this x square, so we have numerator which is greater than denominator, so that we are going to use long division, yes, long division, where we are going to take this x and divide with 1 plus this x cubed over 1 plus x square, so that to reduce it in order to make it easy for integration. So we have x cubed, by long division we divide with 1 plus x square, so here is plus 0x square plus 0x. So what we are going to do here, we are going to put x in order to multiply. Here we have x cubed, here we have x times 1, that is give us x, that we play plus x. Okay, so we multiply by negative, so this cancel each other and we remain with this negative. We multiply here negative x. So what we are going to do now, we have remainder and we have division and we have polynomial where we have x, so that we first write this one where we write x, and because we have remainder, we are going to negative x over this one, 1 plus x square, that is I3 will give us integral of 1 to 0 x negative x over 1 plus x square dx. So we are going to integrate this one. After that, we have I3 equal to integral from 0 to 1 of x dx negative integral of x over 1 plus x square dx. So this, if you see this is the integration of I1. So this is I1. So what we are going to do, we are going to find integral of this x only, because this is, we get it on I1, so where we get it is equal to, where we get it is equal to 1 over 2 ln of 2. So we are going to focus on this integral. So where we have integral from 0 to 1 of x dx, that give us, so when we have a polynomial, we use this formula where we use integral of x power n equal to x power n plus 1 over n plus 1. This is what the formula we are going to use. So we are going to use this formula. So x dx equal to x, here we have 1, we are going to add 1, that is square over 2. So we have to put this boundary. So we are going to plug this into this question, where we have 1 square, that is 1 square over 2 negative 0 square over 2. So where we have 1 over 2. So our purpose of our equation is to find I3 plus I1. So we have I3, we get it. So where we have I3 equal to 1 over 2 negative 1 over 2 ln of 2. So we are going to plug into here. So where we have 1 over 2 negative 1 over 2 ln of 2 plus 1 over 2 ln of 2. That will give us, here we have negative this and positive this cancel each other, where we have I3 plus I1 equal to 1 over 2. This is the question, this is the solution. So what we are going to do next, we are going to deduce I3 equal to 1 over 2 negative I1. This is deduction, okay? So what we are going to do next, we are going to see on our equation. So here what we have, we reach on this C, show that our natural P, I2P plus I2P plus 2 equal to 1 over 2P plus 1. So what we are going to do here on the question C, we are going to plug this as n. So we will have I2P equal to integral from 0 to 1 x power. This is act as n, so we are going to plug here x power 2p over 1 plus x square dx. Okay, so I power 2 p plus 2, also we are going to plug on the n. So what we will have x power 2p plus 2 over 1 plus x square dx. So in our question they tell us, show that all natural p I2p plus I2p plus 2 equal to 1 over 2p plus 1. So we are going to prove that if you take the integral of x power 2p over 1 plus x squared dx plus this x squared power 2p plus 2 over 1 plus x squared dx will be equal to 1 over 2p plus 1. Okay, that is what we are going to prove. So we are going to prove that I power 2 I 2p plus I 2p plus 2 equal to 1 over 2p plus 1. So this is what we are going to find. So we have I2p plus I2p plus 2. So we have it here. So we are going to add this all 0 1. So here we have x square p over 1 plus x square plus x 2p plus 2 over 1 plus x all the dx. So what we are going to do here, we are going to put together because they have the same common denominator. So we have 0 1 integral. This is integral. Yes, this is integral. So here we have 1 plus x square. So we are going to put together x2p plus x2p plus 2 dx. We have a 0 1. Here we have x power 2p plus x power 2p times x power 2. So this is this when we expand. So here dx over 1 plus x square. So what we are going to do here, from here we are going to factor out x square power p. All is the same. We are going to factor out. So we have x power 2p factor. Here it will remain with 1 plus here we have x square dx over 1 plus x square. So as you see, this and this is the same, so that we are going to cancel each other. So we have integral from 0 to 1 x power 2p dx. So we are going to integrate this one by using that formula where we have integral of x power n that equal to x power n plus 1 over n plus 1. So the next things here, we are going to find this one. So we are going to, what we have here, we have x power 2p. So integration of that, we have x power 2p. We are going to use this formula where we plus 1 over n plus 1, so that we have n of 2p, where we have 2p plus 1. So we read the boundary from 0 to 1. So what we are going to do, we are going to plug this value of this integral. So what we have here, we have x power 2 p plus 1 over 2 p plus 1 0 and 1. So we are going to plug this value inside this. So where we have we are going to put where x is, so 1 will be placed here, so we have 1 power 2p plus 1 over 2p plus 1, negative 0, that is also 0. So what we have here, 1 power 2p plus 1, 1 power any number is also 1, so that we have 1 over 2p plus 1. So that means that I2p plus I2p plus 2 equal to 1 over 2p plus 1. That is proved, because we have 1 over 2 p plus 1 equal to 1 over 2p plus 1. So this is the C of our question. So now we are going to calculate I2, I4 and I6. So we reach on sub-question D, where we have to find I2, I4 and I6. So from here, what we are going to do, we are going to deduce like we do on I3. So I2 equal to, that is in our equation we have I2 equal to x. We replace this n here over 1 plus x squared dx. So what we are going to do here, we are going to integrate like what we do in sub question number 1, number A and number B. So what we are going to do here, because we have the same degree, also we can divide with long division. So where we have x squared divide with 1 plus x squared. So what we are going to do, we are going to, this is 0x plus other things, so 0. So here we are going to put what? Let's put, here we are going to put 1, okay? 1 times here we have x squared plus 1. So what we are going to do, we are going to multiply with here with negative. So here we have negative, cancel this, we will remain with negative 1. So what we have here, we have this constant negative this over this. So we have I2 equal to 0, 1 over 1 plus negative 1 over 1 plus x, so dx. So what we are going to do, we are going to integrate or separate. So where we have I2 equal to integral from 0 to 1 of 1 dx negative integral of 1 over 1 plus x dx. So we have I2 equal to integral from 0 to 1 dx negative integral from 0 to 1 integral from 0 to 1 1 over 2 1 plus x squared dx. So what we are going to do, let's do it separately, where we have integral of 1 dx equal to x. Here we have, we place here with 1, that is 1, and let's integrate this one also. 0 1 1 over 1 plus x squared dx. This is equal to arctan of x, that is arc tan of x. So we replace with 0 and 1, so we have, when we press here with 1, so we have negative 1 arctan of 1, that is 45, so that is pi over 4. This will give us negative pi over 4. So let's put it together. So we have I2 equal to this 1 and negative pi over 4, that is I2. So now we are going to search for I